All right. Well, I am Jay Egg, and I'm super glad to be here this afternoon with everybody. What an amazing panel we have here today. But the topic of this panel, grid interactive heat pumps, is really fascinating and intriguing to me. And let me just say something about that before I introduce our panelists and let them go for 8 to 10 minutes each. I have often said, if you listen to me speak, that most of the concepts that I've enjoyed in my 60 plus years of life kind of got formulated in my mind at 10 years of age. At 10 years of age, I was sitting in a cold bedroom because my parents couldn't afford to heat this massive house with 9 children, and wondering why we couldn't store all that heat from the summer to use in the wintertime. And what about all that cooling that we do in the summertime and the rejected heat? Because I already understood the concepts of air conditioning, heat transfer, and fluid flow in the Carnot refrigeration cycle, because as a third-generation plumber. So I also didn't understand all of the, I wanted to know why somebody hadn't invented a way to do this storage. Now, the other thing that I conceived, and I actually wrote about it in my first book, was why our appliances couldn't eventually talk to one another and say things like, you know, because we already had we were going through the energy crisis and we were already having these issues. And I'd say, well, why can't the dishwasher talk to the domestic hot water tank, which talks to the air conditioner, and take turns hitting the grid at a time when it's most practical? And so I actually wrote about this in my first book, and I talked about this. Now, this was 2010. This was before we really had the capability we didn't have Alexa and things you could talk to. So when John conceived of this and talked about the advances that NY-GEO has made with the electrical grid and heat pumps over in Europe, I actually didn't know we had come along that far. And so I'm actually going to learn a lot more from this panel than maybe most of the people in here, because I'm planning on introducing what these good gentlemen are going to be talking about to some cooperative clients and explaining to them how they can implement these systems in advance and be prepared for smart grid heat pumps or grid interactive heat pumps. So our panelists today are Dion. I better do this real quick. No, I'm not going to do it. You guys can read it later. It is, I should read one part. The smart grid is activated when a signal from your utility will influence the control of your electrical appliances, just as we were talking about. While this isn't pervasive, there are a number of ways heat pumps can be responsive to the electric grid pricing while also lowering demand. I think you're going to be fascinated with what you're going to hear today. We're going to listen to Dion Harmsen from Aztech Geothermal, who actually lives in Sweden and Switzerland. I thank you. That's different. Yes, I appreciate that. I think it's fascinating that John, who I consider a brother from another mother, has international employees also. We have a few employees from over in Reykjavik. Get a lot of great talent there. Dion is supporting Aztech's commercial design team in the U.S. with building energy modeling, ground heat exchanger design, engineering CAD drawings, and prior to Aztech, he spent 10 years as a site manager at the International School of Zug, Luzern, in Switzerland. Bob, who everybody knows that's been in this industry, and I'm grateful to be, this is the first time I've ever been able to be on a panel with him. He is an icon in the industry. Since 1981, he was employed at the newly formed WaterFurnace in 1985. I know Dave Hatherton well, and Dan Ellis well, and I'm sure you have a lot of war stories to talk about them, and you're the last person I'm getting to know because that's how things go. So thank you for your service and research in this over the last 30 years. We're going to hear from Bob. And then Mikko Ojanne, Rototec Europe, who was welcomed into New York the same way I was 10 years ago when I was at the very first NY-GEO that we had at the local college here that has truly a thermal energy network there too. So we heard about them wonderfully in the one of the plenaries. They love working close to people from all parts of the world, always curious about what they can do better. By the way, I translated this from the description on LinkedIn, and he says, "Now we go." And so I love that. All right, so without further ado, I'm going to change the clicker over to Dion.
Thanks.
There might be some.
Thank you.
Thank you. As part of my role, I was tasked with identifying high auxiliary heat users through WaterFurnace's Symphony cloud-based monitoring platform. Symphony collects a comprehensive range of data from customers' geothermal systems to enhance performance monitoring, energy efficiency, and user convenience. Currently, Aztech has over 300 customers connected to the system. I've reviewed these accounts to pinpoint operational inefficiencies and efficiency. Together with my colleagues, we compared them against initial system design assumptions. The parameters I focused on included auxiliary heat, to identify users with a high auxiliary heat consumption, heat pump staging, to evaluate whether staging behavior reflected proper system sizing, loop pressure, monitoring for abnormal highs and lows, minimum and maximum entering water temperatures to compare against design calculations, and total annual kWh. From the 300 plus users, 35 were flagged as high auxiliary heat users, meaning those with an auxiliary heat accounting for 5% or more of the total annual kWh usage. Upon further analysis, 50% of these high usage cases were due to thermostat setback, which triggered auxiliary heat. Other common causes included new installations where the ground loop was not yet connected, equipment failure, either in the heat pump or the ground loop, requiring repairs, and undersized system and/or previous sizing methods. This is a screenshot from the Symphony website. On the bottom graph, you can see the blue line is the main temperature zone, and the red line is the entering water temperature. On the top graph, you see the energy usage. Light red is part mode compressor, red is full compressor mode, and dark red indicates auxiliary heat. This example did not use any auxiliary heat. However, this customer definitely did, with 35.4%. This person had a setback of 6 degrees, going from 67 degrees Fahrenheit to 73 degrees Fahrenheit. Together with it being an old home built in the 1920s, resulted in a high auxiliary heat usage. The homeowner is aware that their building envelope needs an improvement, but also contributed to the high auxiliary heat percentage. In this case, is the 3-ton heat pump. Auxiliary heat represents a larger share of the total in smaller heat pumps. This user showed no obvious temperature swing on the main graph, but further investigation revealed a 5-degree setback, nighttime setback, sorry. The auxiliary heat is used throughout all the heating months. This cost 7.5% annual heat load. Reducing setback. During the initial walkthrough, we informed customers on how temperature setbacks can actually lead to higher energy usage with geothermal systems. Unlike oil or gas furnaces, ground source heat pumps are most efficient when set to a constant temperature, following the principle set it and forget it. So why is setback a problem? When a customer lowers the temperature and later raises it again, the system responds in stages. Part load compressor mode engages first. If the desired temperature isn't reached in time, the system shifts to full load mode. If it still falls short, auxiliary heat is activated, which is far less efficient and increases energy consumption. To address this, we reach out to the customer to suggest no setback. If they still want a setback for comfort reasons, we suggest less of a setback, or we can program smart recovery mode. This allows the system to gradually return to the desired temperature without triggering auxiliary heat by starting earlier and adjusting more efficiently. Previous sizing methods included the use of auxiliary heat to about 5%. We moved away from this, but in older systems like this one, you can still see this. The example has no setback and basically uses all its auxiliary heat in the 3 coldest months. It's a good system with no setback, a well-insulated home. The customer is the set it and forget it type of customer. However, 13.3% of their energy use came from auxiliary heat, primarily due to a system repair, during which backup heat ran for a week. Online platforms like Symphony can be powerful aids for optimizing both existing and new systems. They allow us to identify inefficiencies early, including operational issues and poor user habits. One key finding is that thermostat setbacks often lead to increased auxiliary heat use, reducing energy efficiency. This is a cultural change, as most people were taught to set the thermostat back at night or when they aren't at home. This not only impacts individual system performance, but also places a greater demand on the electrical grid. Implementing smart recovery strategies could significantly reduce energy loads for homeowners who prefer using setbacks. Thank you.
All right, Bob, come on up and bring your Oh, you got it for him? Okay, thank you.
Good afternoon. I'm going to take a slightly different tact and try and represent the whole air source and the ground source heat pump industry and talk about the demand response capability and what's been going on and kind of the state of where the equipment is at. And I'm going to talk just mainly about the cloud solutions themselves. And so the first one is an IFTTT potential solution. Make sure it's clicking here. So IFTTT is if this, then that. And if you're not familiar with that, smart home technology is ever changing, and there's a lot of products and manufacturers to individually consider. So it gets complicated to try and get this utility with this heat pump manufacturer and get their clouds to talk to each other. And IFTTT gives you kind of a shortcut for that in some ways can offset that, and I'll show you that here in a second. So the manufacturer can set up a proxy server with API access, and then that can allow the utility and the manufacturer's cloud to talk to each other. But I said the magic word API, so I'm going to talk about what is an API, because people, if you're into this kind of thing, you hear API mentioned about 50 times. So API is an application program interface, and the best way I could describe it is if you look at the two pictures there. If you have a house and you want to share a cup of sugar with your neighbor, you could call the neighbor up and say, "Hey, just go to the house, grab your cup of sugar, and no big deal." Of course, they could go in, they could rob your house and do whatever else they want in the house. They could turn your heat pump on. They could do all kinds of stuff and damage in the house. So that's without an API. With an API, you could program. It's kind of like a butler that would answer the door there, and when you come, you could actually say the butler can get you anything they want within reason, but they can't go into the bedroom, they can't get money. And so the butler is programmed to retrieve the information that is really pertinent to them. And so that butler protects your whole house, but still allows access in and out. The requirement there is that API, that butler, has to be programmed specifically for that information. And so that's where the extra work at the cloud level comes in, is to create that API. So here's how it works with the IFTTT. You can see that the Amazon, or in this case, the IFTTT cloud is here. And so the heat pump cloud creates that API and we can actually create some tools so that these two clouds talk together from the equipment. And the result is you can do utility demand response. I'll show you some examples here in a second. The first level, generally, most of these products have what they call first level, which is a general peak. This kind of sets you into unoccupied set points during the month of August, so to speak, for cooling. The second level are critical peaks that may only happen a few times a year, and there may be something more serious that you do with the equipment and shut it down for that. But most of these will require some sort of positive feedback from the equipment and give that response back to the utility so that they know when they ask for it that you have actually appropriately responded to that. So the IFTTT applets are one of those first steps to that utility demand integration. And what I've shown you here is an example of some of the applets that are available for some manufacturers. Some of them are thermostat manufacturers. Some of them, are various people that have interaction with Commonwealth Edison applets. So this is the Chicago area. So there are some utilities that have made this available. So Commonwealth Edison has got some interfaces on this, and I would call this more on the DIY level, where you, as a homeowner, can actually get these applets, download them, and deploy them on your own piece of equipment. The downside of this particular technology is it does require a little bit of a techie consumer to actually implement. It is a fairly simple communication and some simple demand response, and there's not a lot of verification with it. And only a few utilities have utilized it, but it is that first level. So it's not been a super successful, I would say, from that perspective, but it was a kind of a first try. The next one is really demand response using the utility and the aggregator directly with API solutions on both sides. And so on this one here, you actually have a cloud for the heat pump manufacturer and then a cloud for the utility or aggregator. And then these two clouds have to talk back and forth. And the way this works is you really have to be cloud to cloud for each component. So in other words, Duke Energy would have to talk to Trane or vice versa to really get this to work. So you can see how complicated that would be to have every utility talk to every manufacturer and have those APIs set up so that they work. And that's part of the reason why it's been a little bit delayed. But again, the utility response is generally the same. You've got a general peak and a critical peak, and you want to get that positive feedback from the equipment to the utility. More advanced features are like dynamic pricing response and that sort of thing are also coming into play, and you'll see some of that. So here are the demand response protocols that are popular today, that are at least out and circulating. CTA 2045-A was really made popular mostly by component manufacturers, water heaters. I think some of the kitchen appliances use CTA 2045. It is diminishing in use because it's limited in its capability, but it is still out there. OpenADR 2.0A was introduced and has been in use for probably 10 years by most of the air source heat pump manufacturers in their higher level product. It was a requirement for some of the NEEP program and some of those types of things where having that level of OpenADR 2.0 was desirable. Unfortunately, not many people have really been using the 2.0 protocols from the manufacturer's level, even though they've had that available in their equipment. OpenADR 2.0B is an expanded capability variation of that, getting more into the dynamic pricing and expanding the capability, that sort of thing. And then I think finally OpenADR 3.0 was kind of a complete redesign of the OpenADR protocol, and it is a much easier programming variation. If you see the code from OpenADR 2.0, it's massive to do, job A, and you look at 3.0 and it's a much smaller code. And so they were actually having problems getting the OpenADR 2.0 code inside microprocessors and stuff in the heat pumps because it was so detailed and massive. So OpenADR 3.0 is really where everything's headed with that, and it does have all of those new things in there, and it's gaining traction as a solution. If you're interested in what kind of commands are there, it's hard to read all these. I'm obviously not going to go through them, but basic IFTTT has these kind of commands that you'd want to be using. You got energy monitoring, equipment status, demand management would be one of the other topics. Then you get into the OpenADR 2.0 commands are up here, and then the CTA 2045 commands are down here. So this is an example of the kind of data access and that the protocols would really get into with the heat pump. And so if you really want this slide presentation will be available so you can get into the details of that, but they're in the standards. So here's where we're at, and AHRI 1380 is a demand response standard that was developed for AHRI or by AHRI that includes both CTA 2045 and OpenADR 2.0. And as I said, it's been out for nearly 10 years. It's been in a lot of the variable speed and high-end heat pumps for most of the manufacturers, but it's largely gone unused because there's no utilities have been really using that program yet. The next revision of that standard is currently underway, and OpenADR 3.0 is part of that to kind of help, I think the 1380 committee is feeling that the 3.0 is the next logical step, and utilities are more excited about that. So hopefully it'll work out a little bit better. AHRI 1390 is a commercial variation of that, but instead of just demand response for heat pumps, you got to think about 1390 as actually looking at the whole building. And so you've got BACnet, other building protocols that are all part of that. And that standard is brand new and is under development right now, and then probably we'll have something out in 2026 as well. So 1390 is going to be very important, obviously, on the commercial front. So lastly, the utility aggregators so far have mostly gone their own way. So no one has really brought the whole industry together. There's a lot of custom hardware systems still out there, utilities using thermostats, even some of the water heater type controls for demand management that's been used for years are still prevalent if there is a program. 1380 is 10 years old, and the manufacturers, the heat pump manufacturers, have put that into their product, but very little activity so far. So right now, the cloud solutions have been limited, but the industry is hopeful, and they are getting together more and more. This OpenADR 3.0, they hope, is going to unify and consolidate that whole industry around maybe a single protocol. So that's really all I've got. Thank you.
Thank you, Bob. I know I have a lot of questions, but we're going to wait till the end after Mikko comes up. Mikko, thank you.
That is here. Backwards, forwards. Yeah.
Okay. My name is Mikko. I will talk a little bit about electric pricing in Sweden and Nordics, how it works, and also how we can use it in heat pump and our industry. Little bit about Rototec. We are established in Finland, Sweden, and Norway, and also in US and Germany. We are drilling 6.5 million feet per year, and we have 66 drilling units in this in the group, and mostly we have a lot of the machinery working in Nordics. That's why I bring also the information how we do it in Nordics. About the electric trade, we have like electric grid in Sweden and Finland and the Nord Pole. There is the like flexible pricing of electricity. That means that day before 1 p.m. is the next day's pricing coming out. That means that you can plan how you use your heat pump for the next day, and also you can get out the information how the pricing will be for the next week, like next 3 to 4 days front of it. But it will always be closed 1 o'clock before, the day before. That means that the price is different. The price is different in Helsinki, Stockholm and Oslo, and also in different regions. That means that you can program your heat pump that you are heating on the daytime or nighttime when it's cheapest, and you are using the thermal mass many times for like floor heating. So you can actually heat up the floor higher temperature on the time. And go to the next one. Here is a little bit about most heat pump sold in Europe can be optimized. We are using a lot of NY-GEO and also other brands like Bosch and EWE, and they are prepared already for this grid pricing. And that means that they can take a lot of information about how the weather will be tomorrow, how the pricing will be. Then we can also, with AI solution, heat up the house after that information what we get in. And we will also have changes on the price on the Nord Pole that will come, that today we have hourly, every price per hour, but it will be also end of June this year, they will change it, so it's going to be 4 prices per hour. Then it's going to be more fluctuating up and down. That means that you can have other solution around it. And then also a lot of customers are also looking into solar panel with battery together with heat pump. How you can use the pricing, like buying when it's cheap into battery storage, use it when it's more expensive. And also what we can do in Nordics is that you can sell it back. So you can sell it back for higher price when it's the market price is higher. And actually, I look into some what that will be the pricing if we have 4 times per hour. That can make quite big difference. Between 7 on the morning and 7:30, that can make very big difference between that 30 minutes. So if you can change your consumption from 7 to 7:30, that means that you can save quite much money on that savings. So we really see that trend is coming more in the Nordics, and I believe so that it's gonna come also everywhere, like Central Europe and so on. Or it's also looking at that way. And how we do it is thermal mass many times. We have floor heating, so we are heating up. Or if you have an electric car, you can also have the same, connect all the things together, like heat pump, NY-GEO product together with smart homes. There you can combine and see when are you charging, when are you not, when are you buying and store selling else. So. Yes, and I would say in the Nordics, all across Europe, the share of renewable electric mix increase rapidly, and that thing I think that we have made a lot of changes in Nordics on the electric grid. We have like nuclear power before, a lot of them have had shutting down. We have more renewable energy. That means that our price is more fluctuating up and down. And that's why it's also important for the customer to be aware of that what can I do when I'm running my heat pump? What can I do for savings? What can I do? Different kind of investment in batteries or other solution. And I we really see that customer are looking closer to this and asking for it. And actually, 2 years ago, we have super high price. Like peak was like 10 times more than normal. And then we have also minus price. That actually we go under we have too much production of electricity. So actually it's cost zero. Or you can even give it back money if you use electricity. Thank you. That was from me.
Thank you, Mikko. I have a lot of questions, but this is not for me. I have a feeling our audience will. What's it? Oh, yeah, advances. There we go. I have a feeling our audience has a lot of questions. Trust me, if you don't, I will ask plenty of them because I see a lot of opportunities here and I have a lot of questions. So raise your hand if you would like to ask any of this. There we go.
Jeff Hoffer with Aztech Geothermal. Kind of to tie two of the presentations together, what Dion talked about and what Bob talked about, with the interaction from the grid. Are they smart about how they're controlling the heat pumps, or are they just changing setbacks or changing thermostat settings? Are they smart about, hey, when we're going to lower your temperature, but when we're letting it come back, are they controlling all the way down to the staging and auxiliary heat?
There are multiple solutions for that. Like for variable speed, you can drop the RPM, you can do setback. They give you options for that. And that's in those commands. Several of those are part of that command. So as a manufacturer, you can actually dictate that a little bit, and you have to work out, but you have to verify that you have saved X amount on your on the demand level. In other words, if they say curtailment, they go to level 1, then you've got to prove that you're at the level that they have requested, right? So you can't just do whatever you want to do. You got to do something that meets their criteria.
Right back there, we've got our MIT alumnus.
So
Hi, Rick.
Rick Clemenzi, unfortunately nerd, and so I guess I'm wondering how many utilities are really doing this sort of stuff at this point with the open ADR and such.
Well, my understanding, the meetings I've been in the HRI committee, the 1380 and the 1390 committees, and there are no utilities per se in that, but there are companies that deal with the utilities in there. My understanding is they're on board with 3.0 and that they're all they think they're going to be starting to get something collectively that has not happened yet. And so, in the past, like I said, in the past, they've been working independently, kind of doing their own thing. So that's all I know, is that there's an intent to bring them all together, because you can see, I think Europe has done that a lot better than we have.
Yeah, I mean, I know the universities get calls to drop back and stuff, but none of it's automated or anything, I guess. It's just phone calls like us.
Nice.
While we wait for the next question, I just moved into a new home north of Jacksonville, fairly, new with the latest thermostat, and it's an air source heat pump, Bob. But if you go up to the heat pump in the afternoon, it says on the thermostat, it says in a peak demand mode, you can override it if you want to. Is that basically part of what this is? It's that one. Is that similar to a utility implementing this?
Yeah, it's probably a level of that. So I wouldn't know. Like I said, a lot of thermostats has been the solution of our utilities.
Right.
A lot of thermostats.
Yeah. All right.
Sarah Collado with Siemens. Question for Mikko. Wondering, it's complex, there's a lot of opportunity to save money with this soon-to-be 15-minute pricing. You talk as if homeowners are going to spend their precious brain waves figuring out how to manage their demand to match that, and it just doesn't seem likely. So I'm wondering if there are aggregators or sort of middle zone companies that are doing that for groups of homeowners, or are the utilities, how's that actually getting implemented? You've got the technical capability, but how are human beings actually taking advantage of that technical capability? Or do you predict they will?
Yeah, I really see that. It's different kind of product at your home. Like NY-GEO is one of the heat pump have own solution already, more or less plug and play, to use smart heating or smart pricing. But then you have also, if you have also electric car and you need to make some bigger solution at your home, then you need some connector and some company help you to connect all these things together. And that's actually the lack of them in Sweden. We don't see it's coming more and more, and many of them are AI company with a different kind of solution. We can really see that it's coming small company which helping them with the different kind of hubs, which helps the customer connect all the equipment into the grid system. But from grid side, the price is already there. You have the price in, price out. If you put solar panel, you have battery solution, and you can also with API connect your heat pump directly to the cloud. But then you need maybe have some cloud at home, where you can connect all the other stuff. Micro, yeah, exactly. So that's.
While we're on this tangent and waiting for the next question, Mikko, is Sweden advanced enough that, for lack of a better explanation of what I'm going to say, your electric car can basically feed the electricity to your heat pump to be off peak? Is it basically at that level?
Yeah, exactly. You can actually, if you have electric car and you need peak load, or you need to take back the electricity, you can take also, you can use your electric car storage, electric storage for your house.
And you are there now.
We are there now. Yes.
About.
Yeah.
That is fantastic.
But not in the bigger scale. There, you can use that. You have it's gonna be more and more free in future, where you can cluster connect more together. Now it's more local.
Yeah, it's at the house level, but eventually
house level
they can. That's the ultimate evolution, is to know that there are all these electric cars, and if they have a peak demand situation, they can tap into all those batteries with permission to help with the peak of the grid.
Exactly. So in future will be that if you have 100 car in this area, everyone they know what they can use 50% of that battery and to the grid and so on. That will be the future. It is some IoT or
we've all heard about that, and it's nice to hear you're getting there. But right now, it's kind of local.
More local, yeah.
Yeah. Okay.
Yeah. Matt Rosenfeld here. Quick question also for Mikko. So at least in the U.S., like the way that wholesale electric markets work, day-ahead markets work, right, is there's a load forecast, generators all put in their bids, and there's a clearing price based on that. It's usually, I think you mentioned 1 in the afternoon. It's like 4 in the afternoon here is usually when you kind of have that settlement. And then there's like a true up in the real-time market the following day. This idea of giving customers sort of direct access to the day-ahead market is novel to me. I'm wondering like how, if you have customers essentially responding to that day-ahead price, is there a second adjustment to the price? I mean, if you've sort of potentially messed with that clearing, right? I'm curious how that plays out.
You have actually two way. You can have free pricing, which 75% of Swedish people have. That means that you are following the exchange market, and then you have some people want to fix the price. Then it's actually fixed on the quite high level, and then of course when it's today, when it's fluctuating so much from low, almost zero, up to 7 crowns can be the worst, and have been. That means that you need to have some, otherwise, if you don't want to do nothing, then it's better to have maybe in future a fixed price, because then it's some point regulated in some level. But I think that in future, all the houses will be some way smart homes. This is how I see it. But
while we're waiting for another question, thermal energy storage. You mentioned the slabs, which is mass storage. I love that, warming that up. What about integrating? Most of the geothermal systems there are closed loop, and you have, if I'm not mistaken, it goes into more of an aquifer and it's not grouted, or is it all grouted there?
it's we have closed loop system, lot of vertical drilling, but we don't grout in Nordics.
That's what I thought. Because So, do you practice borehole thermal energy storage there? Is it practical? Is it something you've even thought about? Because I was thinking about if you have an energy event the next day, you could pump heat, for example, down into the boreholes for extraction later. I know that isn't nearly as efficient as doing it in the slab, but you don't want to drive up maybe you have a 3-day event. You're coming into a very cold season. Is that something anybody's ever theorized?
Yeah, we actually do big project in both in Finland, Sweden. There we are doing the thermal storage in the ground, and there is like we actually sometimes have short storage, what we call it. It can be 24 hours or 1 week.
Yeah.
Then we heat it up very much, the water in the ground, and of course the losses is also
lots of losses.
But that doesn't matter sometimes, because otherwise it's anyway go up. So we take care of that and heating up or sell to neighbor, or lot of different kind of hybrid solution. And we have so if you come to visit Sweden sometime, call me and we can go to look some places.
I know there are more questions. I can kick off another round.
One.
There we go. Rick's got another one. Because we still have about 10 minutes, and I don't want to waste the...
Sorry if no one else. I just want to ask, how can I find out about that research that's going on in Sweden with the storage and the bores and the whatever? Who's doing that? And where are the papers on it?
Which places?
You just mentioned, grid to ground.
Yeah.
That.
We are when we make thermal storage for like can be IKEA, can be some shopping center, and it can be industries where they are daily working with, like they need a lot of cooling. Then we are taking that energy to borehole field, and then nighttime they need to heat up the building. Then we take it back. So we actually storage cooling down on the daytime, but nighttime it's like we reverse it and go back again.
So this is being put in commercially now?
Yeah, that have been like many of our project. What we are doing, it's always heating and cooling. This is quite normal in Sweden and Finland.
Yeah, but on a daily basis, I hadn't heard about that here. Because here for extra cooling, of course, people use tanks because it's pumpable. And I hadn't seen anyone do the economic comparison to ground daily storage.
We have daily storage, and also when you do it short, then you have like you drill very close to each other. So we have like not a deep hole, like shorter hole, and closer to each other. So we have different design when we do for different client and different customers. So we have a different kind of industry. Like one of our customer was like they are doing the metal, like putting the silver on the metal, and there is a lot of losses of heating, and they need to cool the bath very fast. And on the daytime we pump it down to the borehole field, and the nighttime they are heating up the building again, and they need that heating, and that was the way how we do it there, together with heat pump, of course.
Yeah.
Good. Sweet.
While we're waiting for another question, I have a question for Bob. You had, I don't know if you meant to, but one of your clouds said Amazon. And I thought a little bit about that because Sensi, when they came out with their smart thermostats about the same time that Alexa was really kicking off, they're one of the manufacturers that asked me to outfit my house with the Alexa system and be able to use their smart thermostat and write an article about it. And I became addicted to that. And I see that as a remarkable opportunity to do that cloud to cloud. Is that what you're thinking is going to happen?
Well, we actually launched that here several years ago, but got very little excitement about it at the contractor level. But essentially, it works the same way as the IFTTT, where you would have commands that you set up through your API through Alexa, and then you could have that as well. But you would have to have a utility. So we did the Alexa side, which is change your thermostat, that kind of thing.
Right.
But we did not implement the demand response side of that, which would require utility to be involved in, to broadcast when those peaks were going to be and what critical response you're going to have to it, that sort of thing.
Yeah. I see that as such a complex, but simple and elegant, such a complex herding of cats, meaning all the utilities, and it would take somebody with that type of massive reach to be able to get them and say, okay, everybody, come join this cloud. We'll have our cloud securely speak to yours. And that's what I saw there, and it was brilliant. It looked like the final evolution for where WaterFurnace is trying to go. So, wow. All right, who's got another question for this amazing? Did I see a hand? Okay, you're already up. Good.
Yep. Yeah, afternoon, everyone. Austin with Aztech Geo. So I guess I'll address the beast in the room, so to speak. Most people, after they spend a large sum of money on a geothermal heat pump that provides some of the most comfortable cooling that they've ever experienced, on those peak days, the last thing they want to see is the system turning off because of peak load demands from other sources of electricity pulling on that grid. So how do you convince people to hand over control of their thermostat after making this investment on a personal level and potentially sacrificing the comfort that they've spent so much money to implement?
While the panel thinks about it, one of my favorite things to do is to be dealing with real data, real-time data, and realizing it's kind of like the guy who will drive across town to save 1 penny on a gallon of gas. Yeah. But I like that kind of, and as a homeowner, I will give away some comfort to say, look, I saved $17 on my electric bill, and I only got warm for a half an hour. So I don't know how many people are like that, but I love if I can just check a box and say do that as long as I have an override, I'll do it. That's just my, I'm just like that. I feel like I did something good without having to do a lot.
I'll take a stab at it. I think you're going to have a whole area implemented, so you're not going to be alone. But number one is if you have the higher technology, like a variable speed unit, for instance, you don't have to completely shut the unit off. And since we do have such a lower kW draw, you can actually maybe still provide cooling through that period where your neighbor with a single speed or a 2-speed air source unit might have to be completely curtailed off. So you have some advantages there, and that's what I would sell, is that we have a better technology that we can implement the curtailment more effectively and still keep you comfortable.
That was a great question. Thank you. We've got another one right here. Thank you.
Manisha Rane Fondakaro, Soul-led Solutions. So for implementing this idea, how about doing it in a not demand response manner, so that give that control to the utility and they will control your geothermal. Thank you.
I think that is, did you understand that question, panel? I think what she's trying to say is, why not let the utility control your geothermal heat pump? And that's essentially what you're doing if you do this, right?
Yeah, during those time periods, right?
Mm-hmm. Yeah, so you were concerned, if I understand, Manisha, that the homeowner had to actually physically be involved and say, I agree, I flip the switch, I can turn it off. But I can confirm to you, having had that system, and actually in my last 2 houses, if you subscribe to the utility program, and I was playing a little bit dumb, they have the ability to go in and tell your thermostat, we're in a demand situation. We're going to allow your temperature to go up from 78 to 81 during that time. And you realize you're getting hot during that time, and you walk up to your thermostat and you go, this is where I go. Yeah, I get $17 a month if I can make it 15 more minutes. And so I kind of go, yeah, I can make it, or something. Rick?
Sorry.
That was a great question, though, about the user interface.
So I saw this earlier when you were speaking, and Bob, about the standards and stuff, and then it just made me think of it again from that question. Is there a point where people have been talking about like pre-cooling? For example, if you gave the utility the control, then the utility could say, okay, I know we're going to hit peak in 3 hours. Let's cool these places down a little extra, drop them another degree or 2, and then we can turn them off when we hit that peak. I mean, that makes so much sense, but of course, then the customers have to be willing to say, I'm willing to tell the utility to make me burn more electricity than I need now because I know I'm going to help the system, but it's going to work out in the long run.
Yes, that's all possible, and that's why from 2.0 to 3.0, where they get the dynamic pricing, that's where all the sophistication comes in, where the manufacturer can have some of those kind of capabilities programmed in. So that's all part of it, but we just haven't got into it yet with the utilities to get some unified, this is the way the program's going to work, and let's all try and get on board. So,
Mikko, do you guys cold soak your slabs, or do you not have cooling events where you would need to do that?
It's a big one.
That, in other words, make your slab cooler for an air conditioning event?
What is that?
Make it colder. Do you have air conditioning needs?
Yeah. We have.
So you mentioned you use the slab for thermal mass. Do you actually cool the slab down during an air conditioning event, or do you not have those?
Yeah, we
we have different. We have like two-way systems. So actually, we have like floor heating many times, and then we have like fan cooling from geothermal.
Oh, okay.
So this is for geothermal, also like passive cooling, we call it. So we have more and more heating and cooling, and more balanced this time. Specifically, if we go to project that bigger, like it's always like balanced heating and cooling system.
Yeah, the larger it is, the more balanced.
And
Yeah.
now it's starting to come to residential home also that you have also heating and cooling.
Yeah.
But then you have the two ways, so like floor heating, and you have like geothermal fan on the or with the air. Sure.
Now, when you say that, I'm sorry. Does the fan convect through the floor somehow?
The fan is like connected to the brine system. So
the brine system.
So they're like going behind, connected directly to the loop.
Okay.
So and circulation pump. So it's actually taking the free cool from the ground.
Oh, because your ground temperature is what? Can you convert to Fahrenheit for all of us?
Yeah, it's like 6 degree. I don't know how much that is actually 6 bar.
6 is about 50?
50 or something that.
Yeah. 42. Wow.
42, yeah.
Oh, yeah, they don't even need active cooling, do they?
We don't need active, I know,
No.
exactly.
Okay. I can do it. Fantastic. By the way, for those that don't know, in the upper Midwest, there are a lot of active passive cooling systems, including local 455 Pipe Fitters Union in Minnesota uses passive cooling off of the groundwater temperature because it is in that temperature and they're able to cool the whole place. So that's a lot. We have, John.
Yeah, I'll try not to make it long. Are there any utilities left in the room? Folks with electric utilities?
There we go.
Okay, we got one Lone Ranger. Thanks for hanging out. I'm just a little curious. I make a comment, interested in your responses. But when you go to utility conferences and you start to talk about demand response, and you kind of talk about the need of the response, and then you talk about control, the control part, the utilities typically don't like to dictate to consumers what their experience is going to be. So when we start talking about integrating through an API with Bob's Butler, and you just turn it over and you opt in and you turn it over and let the utility operate it, and they pre-cool, preheat, do what they want to do, shift the peak. All those good things seem logical from a physics and operating standpoint. But utilities are even hesitant, from what I interpret, that even when consumers opt in, if they don't like it, they're not going to be happy. And that can either mean they're complaining to the utility directly, or they're doing what is the rage now. You go on social media and burp about it, and then the utility's got a PR issue on their hands with their consumers, and that's ultra sensitive. So the idea seems, for me, it's the utility control piece is pretty messy for the utility. And it's going to be, how do you sophisticate the integration of controls and management that the consumer is in total control over, and that they have the information and the data that they can respond to try to optimize their own cost, and what that cost equity trade-off is for whatever comfort compromise they're willing to do on that particular day. Because if I'm at home alone in my house, I may have a bit different view of saving $3 and doing a setback on the thermostat than if I would just politely say I have my whole family there. There may be differences of opinion. If anybody's ever argued about the thermostat in your house, it gets real pretty quick. So I think it's going to be a little gooier. It won't be just as simple as hit the button, opt in, and Con Ed runs your thermostat for you, and everybody's happy ever after. I don't know that it's going to work that way. You guys are shaking your head.
I think we have a response over here in the blue shirt.
Yeah, I can just in myself.
We need to get you a microphone. You can grab that one. Yeah, there you go.
Matt's the lake one.
I see John Shavako back there, and I don't want to catch his wrath.
I'll speed talk. Josh Einbinder, NY Green Tech. I live in Long Island. We have two utilities, PSE&G Long Island, who handles the electricity. and we have National Grid, who does gas delivery. We live in a very high density population area. Recently, PSE&G Long Island, our utility, implemented time of day usage rates across the footprint, giving the customers an option to switch back to standard rates. But the point being, peak hours between 3 p.m. and 7 p.m. are now at a reduced rate, including delivery. They separate delivery charges and power supply charges because LIPA does power supply. But during those peak hours, the per kilowatt hour rates are higher between 3 p.m. and 7 p.m. and they give the customers the option to, use their appliances and outside. They also have a super off-peak rate, which allows customers to save even more between 10 p.m. and 6 a.m. in the morning at even lower per kilowatt hour costs. So PSE&G Long Island puts the impetus on the customer to utilize electricity as they wish, but you're going to pay during certain peak times. I guess I have a question for Bob. With the APIs on a consumer level, on a residential level, could those APIs be used to allow customers to, without having to manually go and turn down their thermostats or?
Yeah, and the big issue here is, that's good for like the general peaks that you're going to hit in August, when it's hot out. But when you have instantaneous peaks that happen 5 times a year that are the real big spikes that cost the real money, you don't know exactly when those are going to happen. And so that's why, plugged into this API that the utility can actually do something about that peak, those 5 or however many they have a year. That's where the penalty comes in for the utility. So you couldn't ever have a consumer solve that problem. I don't see how.
Well, thank you. I know we're at the end of a wonderful 2 days. John, Shivako, Aztech, NY-GEO, WaterFurnace for sure, constantly present in making a huge difference in the industry.